Okay, so let us start with the implementation of for a single linked list. So we are going to use two classes. One is called the node class and the other is the list class. So the node class, as you can see, will store information about a particular data and then the next node pointer, and then the single linked list is like a list of these nodes. Okay. Alright, so the node class is going to have the two member variables declared as private, the int, and of course this is the type of data we want to store. We could have here any object also if you want, an employee object. Okay, so int data, and so you see here the next node pointer stores the address of another node. So if you have to store an address of an integer where an integer is stored, you would say int star and then the pointer name. So here we are going to store the address of the next data node or next node in general. So we have to use what is called node star and then use some name for the pointer, and we'll give some meaningful name and call it as a next node pointer, basically to indicate that it stores the address of the next node further down in the list. So that's the way you should interpret this. So this is a pointer that stores the address of a node. So that's why we say node star. Okay. Now we have a no argument argument constructor that doesn't do anything. So we'll use the set functions to set the data, set the member variables. So we have set data and int we'll pass some local variable d, and then we say this data, the member variable, equals to d. Similarly, we have the get data function that returns this data. Now the set next node pointer is a member function that can set a value for the next node pointer, and again, as I said, this is of type node star, so it's a pointer showing the address of a node. So we have to also pass an argument that corresponds to a pointer to the node object. So node star some variable node pointer, and I can set next node pointer equals that node pointer. So basically whatever the address is passed through this node pointer is now you assign to this next node pointer. And then you can say get next node pointer, and its return type it's node star because you're returning next node pointer, the address. So you have to use node star as the return data type. So this is all the node classes, the two member variables and the set and get functions for them. Okay. Now the list class. So again, this is a single linked list, so we just need to use a head node, and the head node is kept track of using the head pointer, and again the head pointer stores the address of a head node, which is also a node. So we'll say node star, and as you can see, it doesn't really matter if you do not know this thing in pointers. You can say node and then space star head pointer, or node star space next node pointer. It doesn't matter where you put a star along with the node or along with the variable name. Okay, actually the convention is to use something like this, node star. Here I just said put it the other way. Either way is okay. Alright, so the constructor for the list class, it doesn't need any argument. So basically in the constructor we are going to set up the list or initialize the list, and so initially the list doesn't have any data. We have to just set it up and then populate the data using some some member functions, and we'll see that we'll use the insert functions to actually fill the list. Alright, so the constructor for the list class will just set up the head node. So we'll say new node, and that's going to create a new node. So the new node, again, this is a constructor we're using, so it's a no argument constructor, doesn't do anything really, so it just sets up the node. So that means the data and the next node pointer are not initialized yet. And this is a head node, so we don't really need to set up the data, we just need to set up the next node pointer, and this is how the head node is. So the data is not set up. Now as I said, we have not yet added the data nodes, so the next node pointer for the head node is set to null, and this is how we do that. So we can access the head node using the head pointer, because the head pointer stores the address of the head node. So let us again assume the head node is stored at address 100. So the head pointer stores 100, the address of the head node. So using the head pointer, we can access the head node, and again we are accessing an object of type node using what? A pointer. So we have to use the arrow operator for the calling the member functions. We saw that for the packet object example in the previous module. So you cannot use the dot operator when you access an object using a pointer to that object. So this head pointer is a pointer that stores the address of the head node, so always you have to use an arrow operator to access any member functions. So head pointer arrow set next node pointer. So set next node pointer is a member function of the node class, and we have to pass what? An address for the head node. And here you're going to pass 0, so that's because basically there's no node further down. Okay, so this is initializing the list, basically the head node, and its next node pointer is set to null. And using this idea itself, we can write one more member function called the isEmpty function. So isEmpty function will return boolean true or false, indicating is whether the list is empty or not. So if the list is empty, it will look something like this. It will not have any data node. Then the next node pointer for the head node will be null, and that's what we are going to check. If head pointer arrow get next node pointer, so we have to get used to calling member functions like this using pointers. So this is a head pointer, so in the address of the head node, arrow get next node pointer. So you're calling this member function on the head node, and that will return the value that you store in the next node pointer, and in this case it is null. So if it is equal to means you're comparing. If the value returned by this function is equal to null, then return true, indicating the list is empty. Otherwise you can return false. So right away with this logic we can come up with the isEmpty function to check whether the list is empty or not. Okay, any questions so far? So you have node class with the data and next node pointer for each node, and then you have the list class that kind of will build up the list starting from the head node. Okay, so let us now fill up the list. So let us assume this is the data that we want to populate in the list 10, 5, 7, 9. So eventually after we build the list, it will look something like this. So we have just created now the head node at address 100, and the head pointer stores that address of the head node. So as you can see here, we don't really need to store anything other than the head pointer in the list as part of a member variable for the list. Using the head pointer, we can access where the head node is, and from there we can access all elements in the list. So we have to now kind of insert each of these elements. So let us look at the insert function that can be used to insert or add data to a list. Now this insert function, as you can see, it doesn't say insert at index. So like in the array, we can have insert and insert at index. So if you call it as insert, that means you're basically inserting at the end of the list. Okay, so whatever the content of the list is, you're adding one more element to the end of the list. That's what we can interpret as by the name insert. Okay. Alright, so I'm going to explain a logic that we'll use several times in this course when you do a single linked list, also in the case of the double linked list too, but predominantly the single linked list use very similar logic. So in all your assignments involving single linked list, in majority of the cases or in almost all of them, you will use a logic very similar to this. So make sure you understand the logic I'm going to explain now. So in order to traverse the list, because that's what we'll end up doing to do anything with a single linked list, right? So in order to traverse the single linked list, we will use two pointers and update them as we traverse the list. So the two pointers, we'll call it some meaningful name called the current node pointer to indicate what is the current node we are looking at, because we can look at only one node at a time and traverse one node at a time. So the current node pointer stores the address of the node that we are currently looking at or currently we want to access, and the previous node pointer stores the address of the node previous to the current node. Okay, So at any time, this is how the two pointers will be. So this is somewhere just a part of the list. There are some elements to the left of this node, there are elements to the right of this node. I'm just showing a screenshot of a list. So let us say there are two data nodes, one at address 300 and one at address 500, and I say current node pointer is 500. That means the current node pointer stores the address of this node. Okay, so when I say current node, that's the node that I want to really look at and process that data node. So the current node pointer stores the address of this node, and using this node we can access the next data node at address 700 further down the list. Fine. Now using the previous node pointer, I can access the node previous to the list. So the previous node pointer, which is a separate pointer different from the current node pointer, always stores the address of the node previous to the current node. Always means we have to make sure it follows this property or this logic, so that as you can see in the functions that we're going to see, using this logic you can accomplish very many things. So the previous node pointer stores the address of the node previous to the current node, and in this example it is 300, and that's where that node is stored. And using the next node pointer of the previous node, we can access the current node. And the next node pointer of the previous node is also the value of the current node pointer, because they should match, right? Because the previous node pointer stores the address of the node previous to the current node. So that previous node should store the address of the next data node, which is also pointed by the current node pointer. So this 500 in this example here is the address of the next data node. Using that you can access this node, and that is also the address stored by the current node pointer. Okay, any question on this? Okay, when you just say I don't understand, what is that you don't understand? Specifically you have to say. Ariel, Maggie.
Can you hear me?
Yeah, what is that you don't understand?
I'm not trying to be offensive. I don't understand nothing.
Did you join on time at 12 o'clock?
Yes, I've been here. I've been on here since you said good afternoon, everyone, to everybody. I'm just
okay. What is that you don't understand? Be specific, because I went over for 25 minutes.
Okay, don't worry about it. I don't understand nothing, so I don't know how that sounds to you or how that, but I don't understand nothing, and I did really good in 119, so I was just letting you know. I mean,
because I went through a packet class example before the first module, and this is similar to that. We're having a class, and then we're having member variables in that class. And this is similar to what we saw in the first module, which is again a review of 119 material. So it comes by practice. You have to go through the code. So I posted all the code. So you have to really practice this. Go back and look at the code, and you have to try out all these examples. So this is in this 2.3. You have a node class that has this, and then the list class. Okay, so it comes by practice, and again, just don't give up if you're not getting right away. You have to continue listening, continue practicing, and it will, they'll say it will click. So one point at a time you'll understand it completely. Okay, so don't just give up that you don't understand things right away. Yes, all these things are in Canvas. All the files, all the slides I'm going through are already posted in Canvas, and they're also posted in the course website. And the code is it's also posted in Canvas. And we have TA starting to work from today, and they are also holding virtual office hours. So if you don't understand anything, you can ask me, either during the office hours or send an email, or you can ask them ask the TAs during the office hours, or also send them an email. And these videos are also going to be there. So when you go, of course, you can say you don't understand a particular topic, and we'll be happy to explain again offline. But if when you ask questions, you try to ask questions as specific as possible. Okay, because that also makes sure you have tried it to read through things and then try to work it out, and you can say I don't understand this particular step. And then we can, of course, to explain that step, we'll be starting from the beginning and coming to that step. But that will reinforce. When we explain those things again to you, you'll be able to get it more clearly. Okay, so we have to work it out again and again. Alright, so let us do the insert function. Alright, so let us assume a scenario like this. Let the list be currently something like this, and with elements 10, 5, 7, 9, the data, and we want to insert another data element, say 30, at the end of the list, and that's what we want to do. And if you can understand this, then that means using this insert function, we can basically build up all this, the entire list. Okay, so let us say we have done that and built the list up to this point, and we're going to insert one more element to the list at the end of the list. So how are we going to accomplish this? Okay, so again, make sure you focus on this logic. So we are going to use this current node pointer and the previous node pointer. So the current node pointer stores, or to begin with, will store the address of the first data node. And where is the first data node? The first data node is the node next to the head node. How can we get that? The head pointer is the only thing that we can make use of to begin with. So the head pointer stores the address of the head node. So on the head pointer, because basically that means on the head node, we can call the get next node pointer function that will return the next node pointer value in the head node. And in this case it is 200. So the current node pointer will then store the value 200, that is the address of the next node pointer in the head node. So calling the get next node pointer function on the head pointer will return you the next node pointer value on the head node, which is this 200, and that's the value stored in current node pointer. The previous node pointer should store the address of the node previous to the current node, and that is in this case a head node. So we can simply say the previous node pointer equals the head pointer. So you can assign pointers like that to the value of one pointer is assigned to another pointer. So we can simply make this statement node star, which is is a pointer to the node object, and I named as previous node pointer. So the previous node pointer stores the address of the head node to begin with. So I can simply say it is head pointer. So that is how we set up the two pointers to begin. Okay. Any question on this? So if it is disconnecting for someone, you can refresh the screen or make sure your microphone is working. Alright, so let us move on. So that's what these two statements do. Okay, so just initializing the two pointers. The current node pointer stores the address of the first data node, which is the data node next to the head node. So you can get that address using the head node's next node pointer value, and the previous node pointer stores the address of the head node. Alright, so as I said, this is inserting at the end of the list. So we are currently at the beginning of the list, and we have to traverse through the entire list and then insert the data, right? Okay, so how are we going to traverse the list? So as I said, we are always going to use the current node pointer as a reference. So the current node pointer is pointing to some node, and that's the node we are going to use as reference. So currently we are looking at this first data node. So we have to check if the current node pointer is null or not. So when the value of current node pointer becomes null, and eventually it will as we go through this code, that means we have reached the end of the list, and there's no more element to access or process. So that's what we check in the while loop as a condition, whether the value of current node pointer is null or not. So here current node pointer is not null. So it is storing 200, which is the address of this node, the data node. So that means we can get inside the loop and traverse further down. So we have these two statements inside the loop. So again, we have to eventually reach the end of the list. So for that, we'll make use of the logic like this. So we will move or set the previous node pointer, which is currently pointing to the node previous to the current node, to point to the current node itself. Okay, so that we can now have two handles to the current node. One is using the current node pointer, you can handle or access that node, and using the previous node pointer also we can access that node. So how we do that? We can say previous node pointer equals current node pointer. So current node pointer stores the value 200, and that's now also the value of the previous node pointer, 200. So now we don't really need two handles to a node. So the why we do that is because we need to move the current node pointer further down. So before we move the current node pointer further down, we need to make the previous node pointer to move first. So that's why we make previous node pointer equals current node pointer. So previous node pointer is now here pointing to this node. And now we can move the current node pointer further down by telling current node pointer arrow get next node pointer. So basically this one will return the next node pointer value stored in that node. So current node pointer pointing to this node, and the next node pointer value stored in that node is 70. So current node pointer get next node pointer returns the value 70. That's the address of the next data node next to the current node, and that is reassigned back to current node pointer. This is like in simple math, you do x equals x plus 2, right? So whatever the x value is, if x is 10, you say x plus 2, it becomes 12 and is reassigned back to x, and the new value of x is 12 and it is not anymore 10. So same thing, when you can do current node pointer arrow get next node pointer, and that way you access the current node and retrieve the value of the next node pointer in that current node, which is 70, and assign 70 as now the new value of current node pointer, and that way the current node pointer is now storing the address of the next data node. So that's a very important logic to understand. So now that's the loop. So at the end of the loop, which is an iteration, we have retained this property that the current node pointer is pointing to the current node that we're looking at, because so previously we're looking at this data node, and it's time to look at this data node, the following data node, and that's what we have done. And the previous node pointer stores the address of the node previous to the current node. Okay, so make sure this property is satisfied throughout in all the iterations, at the beginning of the iteration and the end of the iteration. So let us now continue the iterations. Current node pointer is null or not. It is 70, not null. So again get inside the loop and move the previous node pointer first to the current node. So the previous node pointer is set to current node pointer. So the previous node pointer takes the value 70. That means it will point to this data node. And now the current node pointer is moved further down. So we can say current node pointer arrow get next node pointer. So the next node pointer value in the current node is 500, and that's the value that will be stored in the current node pointer now. So current node pointer is now pointing to this node, and that's the loop, that's iteration. So continue this process. Check if current node pointer is null. It is not null. So move inside and make the previous node pointer take the value of current node pointer. So it is 500. And then move the current node pointer further down to the next address, which is 700. Now again check if current node pointer is null. It's not null. So again move now the previous node pointer to the next node. So both are pointing to this node. Now current node pointer can be moved further down. So now you see current node pointer arrow get next node pointer will return the next node pointer value in this current node, which is 0. And current node pointer now becomes 0, null. That means that's the last data node. There's no data node further down. So now you check if current node pointer is null. For the next iteration it is null. So you have to come out of the loop, and then when you come out of the loop you have this logic of setting up the new node, and that's what we're going to do. So we have reached the end of the list. So we started with the head node and traversed through the list one node at a time, and we now have a handle or a pointer that stores the address of the last data node. So think about this. So initially you can access only the head node, and we don't know where the last data node is, so that we can insert this another data node after this last data node. We don't know where this node is, so it's data 9. So that's why we started with the head node and traversed through the list one at a time. And now we really have the address of this last data node. So now we should be able to insert this new node with the data 30. So how do we have access to the last data node? The previous node pointer is having the address of the last data node. The current node pointer is null, because using the current node pointer we have basically traversed to the list and we have gone beyond the last data node, and it is null. But the previous node pointer is having the address of this last data node. So using that you can access this last data node. So how do we insert the new node? So this is the code for that. So we create the node first. So I say new node, and then the address of the new node. So the new operator always returns the address of the object you are creating. So new node, and you are storing the address in new node pointer. So new node pointer stores the address of the new node that we just created. Let us assume the new node is created at address 900, and the new node pointer stores that address 900, and similar to the packet pointer. So whenever you create an object, you're storing using the new operator, you can get the address where that object is stored and store that in a pointer of the same type. So node star new node pointer stores the address of the new node. Now what we can do is, now we need to set up the data for that new node. So how we do that? Call the setData function on the new node. So that's a node object, and we have access to that using the new node pointer. So we can say new node pointer arrow set data and pass the data that we want to create. So this insert function will be called with the data that you want to assign. So we'll pass the 30 to that insert function, and using that you can set the data. Now there is no, and that's the last data node, right? Because we want to append or add it to the end of the current list, and once we do that, it becomes the last data node in the list. Now you see, still we have not linked it up with the list. We'll do that eventually, but we can set up these two member variables, the data. Now there's no node going to be there further down at this time, so we can set the next node pointer value for this new node to be null. How we do that? We can call the set next node pointer function on this new node pointer using the arrow operator, and that will really set up the next node pointer value for this new node. and you can set it to be null. Now, as I said, still they have not been linked up, so that's what we now want to do. So the previous node pointer stores the address of the last data node in the current list. So this is our current list. The previous node pointer has the address of this last data node. Now what we can do is we can call the set next node pointer function on this node and change the next node pointer to what? To store the address of this new node. And how can we accomplish that? Call the set next node pointer function on the previous node pointer. So that means you're calling on this previous node the set next node pointer and setting its value to be this new node pointer that really stores this address 900. So with this statement you can make the next node pointer value for this node to be this 900, which is the address of the new node, and that's basically creating the link, because now using the next node pointer you can access this node. Okay, so the new data node has been linked to this list, and using starting head node, now we can visit the list, traverse the list and print all the data 10, 5, 7, 9, 30. Okay, so this is the insert function to insert a new data node at the end of the list, and you will repeatedly see this logic throughout this module and several times in this course in your assignments. Okay, and the next one also we are going to use a similar logic, so things will be even clearer as you go through that. Okay, there are some questions. All right. Okay, so the addresses are something I came up with. So how do you get 10 for the previous node pointer and 70 for the next node pointer? So let me go back and look at it. There's node 10 and 70. Okay, the 10 is the data. So I'm assuming I have already set up the list with 10, 5, 7, 9. And you can see the addresses will follow once you fix these addresses at again these numbers where I'm creating these nodes. I just came up with these numbers. The operating system will come up with these memory addresses. For the example, I just came up with these numbers. So when I say this is at address 100, this node at address 200, this is at address 70, I came up with these numbers. But once you fix these addresses, the numbers that go inside the node will automatically follow for the next node pointer. So let us focus on the next node pointer. So the head pointer stores the address of the head node, which once I say it is 100, the head pointer stores the address 100. And the next data node is at address 200. So the next node pointer for the head node will be 200. The next node pointer for this node will be 70 because that's the address of the next data node. The next node pointer for this node will be 500 because that's the address of the next data node. The next node pointer for this node will be 700, that's the address of this node. And we just created this new node, its address is 900, that's the next node pointer. And the data, again I came up with these numbers, the data 10, 5, 7, 9, some integers that you want to store, and the 30 is also something I came up with. Is that clear now for Brandon? The address while assigned the node pointer, yes, so the addresses the operating system will come up with depending on where the nodes are stored. You don't need to worry about in your code. So in your code you have to really access them using the pointers, and the pointer will store the address of the particular node. Okay, so when you say head pointer, you see here you say head pointer equals new node. That's the code you are writing, and the new function, the new operator will create the node somewhere in memory, and that address of that memory will be stored in head pointer. So from a developer point of view, you don't really need to know the value of that address. You just need to be able to use that value using this head pointer variable. Okay, so You really need those numbers I have shown there are just for example to illustrate the idea, to using a visualization. uh, is that clear? Okay. When the node is created, Mark Cole's question, it is assigned a memory location by system. Any memory that will be large enough to hold the data. Okay, he's helping me out by explaining. Good. So, like Mark Cole is telling, this the address will be in hexadecimal like this. I think everyone can see everyone else comment, right? So, instead of using hexadecimal value like this, I'm using numbers like 100, 200, 400, 700 for the memory addresses to keep things easy to represent. Okay, right? Any other question? So we'll repeatedly go through this logic. So again, keep focusing and practice out. So draw things like this and try to write down the numbers, and that will help you to understand better. Okay. Alright, so let us now look at insert at index. So insert at index is going to be able to insert at any index. It could be even at the end of the list. So this is a more general function compared to the compared to the insert function, and we'll use the similar logic or kind of like an expanded version of that. Alright, so again we'll use the logic of using two pointers, the current node pointer and previous node pointer, and the current node pointer stores the address of the node that we are currently looking at. So here, as I said, we don't have explicit indexing in the sense that the node class doesn't have an index variable or index member variable to keep track of the index of any node. So when we say we have to insert at a specific index as part of our code, we have to keep track of where the traversal and insert at the appropriate location. Okay, so let us use the same list 10, 5, 7, 9, and I want to insert the 30 now at index 2. That means if this is the list to begin with, think about like an array. 10 will be at index 0, 5 will be at index 1, 7 will be at index 2, 9 will be at index 3. So after the function insert index is called, the list should look like this: 10, 5, 30, 7, 9. So 30 should be at index 2, 7 should be at index 3, 9 should be at index 4, right? If it was an array, and that's a similar thing you want to now accomplish with the list. Alright. So again, so assume this is the current list we have, and let us go through this code right now. So the first two statements are the same. The current node pointer and the previous node pointer are set up. So the head node's next node pointer. Head pointer stores the address of the head node. So using the head pointer, you can access the head node. Arrow get next node pointer. So basically calling the get next node pointer function on the head node, and that returns the value 200, and that is stored in the current node pointer. So current node pointer stores the address of the node next to the head node. That's how you begin with. And the previous node pointer is assigned to head pointer itself, stores the address of the head node. Now we need to keep track of where we are currently in the traversal of the list. So we use another temporary variable called index, is initialized to 0, and that also means that's the index of the first data node. So the current node pointer is currently looking at the first data node, and we always start indexing from 0. So the first data node is considered to be at index 0. Okay, so whenever you change the current node pointer, that's the logic now we are going to use. We have to change the index too. As we move the current node pointer, we will change the index. Okay, so currently index is 0, indicating that we are currently looking at node at the first data node. So the current node pointer stores the address of that node. So now use the while loop as we did before and check if current node pointer is null or not. So it's not null to begin with, so you can get inside the loop. So now this if statement checks if we have reached, as part of our traversal process, the index where we really want to insert the data. Okay, so the insert at index function is called with two arguments, the insert index and the data. The insert function was called just with the data because we are inserting at the end of the list. We don't need to have insert index there. But here we need to insert anywhere in the list. So we'll have the insert index explicitly called. So it will store 2 for this example. Okay. So we check whether index equal to insert index. So in this example, insert index is 2 and index is 0. So index not equal to insert index. So we don't really go inside the if statement and break the loop, continue inside the loop. And what we do inside the loop, if we have not reached that insert index yet, we have to just traverse down the list further down. So we'll move one node down. So the logic for that is to first set the previous node pointer to be the current node pointer. So the previous node pointer will now take the value of current node pointer, that is 200, and then the current node pointer can be moved further down. So the current node pointer arrow get next node pointer will return this address 70, that's the next node pointer value stored in the current node. So that will be assigned back to the current node pointer. So current node pointer is now having 70, storing the address of the next data node. So since now current node pointer is pointing to the next data node, it's the second data node, we have to increment the index. So right away after this statement I say index plus plus. So index is incremented from 0 to 1. So index is now pointing to this data node. So current node pointer index is not a pointer, it's basically referring that it is that's the corresponding node index we are looking at. Okay, so index is just an integer. So current node pointer is a pointer storing the address of that node. Alright, so this is how the 2 pointers are after this iteration. So now again in the beginning of the loop, as a condition, we check if current node pointer is null or not. So current node pointer is not null, it is 70. So we get inside the loop and check if index equals insert index. Index is 1, insert index is 2. We have not yet reached the index. So we can continue moving further down. So how we do that? Make the previous node pointer take the value of current node pointer first. So previous node pointer will be now get 70 pointing to this node, and then move the current node pointer further down by using the statement current node pointer arrow get next node pointer. So the next node pointer for the current node is value is 500. That's the value that will be assigned now to current node pointer, and then increment the index from 1 to 2. So current node pointer is now pointing to the node at index 2, means the third element in the list. So now check as a while, in the beginning of the while loop, if the current node pointer is null, it is not null, so get inside, and now you see index equal to insert index. So index is 2, insert index is also 2. So it's time to break the loop, because we don't want to go all the way down to the end of the list. We want to break right there where we have reached the position that we want to insert. So break from the loop. So breaking the loop means coming out of the loop. So now it's time to insert the new data node. Okay, so let us see the logic for that. So the first 2 statements are basically going to set up the new node and set its data, right? So new node means I'm creating a node and its member variables are not set up yet, but the new operator returns the address of where that node is created. So that is stored now in the new node pointer, and we'll follow the convention of using some address. Let's say it is 900 as the previous example. Again, these are the numbers I'm coming up for the addresses, as I explained already. So you, as the operating system, will come up with those addresses that are available in memory. Now the new node pointer will store that address 900 pointing to that new node, and we can set its data to be the 30, whatever the data that you want to set up. So the next statement, I say new node pointer arrow set data to be the data. So that's straightforward, calling the set data function on the node object using the new node pointer. Okay, so always you have to use the arrow operator when you call using the pointer. The next 2 statements are the ones you have to really understand to link the new node to the current node. So that's what I show here. Okay, so the new node's next node pointer has not yet been set up. We just set up its data. So now we can set up the next node pointer for the new node. How? So the new node pointer arrow set next node pointer, because you see previously the list is 10 5 7 9. We want to make it like 10 5 30 7 9. So following 30, the next data we want to have in the list is 7, and that's the node that is currently pointed by the current node pointer, which is, so current node pointer is pointing to this node, and that is at index 2, and that's the index where we really want to insert, right? So then this data node that is currently pointed by current node pointer becomes the node next to that new node that we are going to be inserting. So that's why now we can make use of the current node pointer and say and use that as the value we'll pass for this next node pointer. So the new node pointer arrow set next node pointer pass the current node pointer as the argument for this function, so that this next node pointer will take up the value of this current node pointer, which is 500. So using this first this statement here, we have set up this blue link from the new node to the current node. Now we have not yet set up this green link so that we can traverse the list from the head node, and we can now accomplish that using the previous node pointer. The previous node pointer arrow set next node pointer. The next node pointer for the previous node is currently 500, pointing to this node. So we want to break this link. We don't want to go now from this previous node from 5 to 7, right? So we now want to go from 5 to 30. So using the next node pointer, where we want to change this. So previous node pointer arrow set next node pointer to the value new node pointer, and using that we can now make the new node pointer for this previous node to store the value, so the next node pointer for the previous node to store this new node pointer value, which is 900. And that way we have set up this link now from this previous node to this new data node. Now we have set up both the links. So from the head node we'll be going to 10 and then to 5, and then the next node is at address 900, which is the data is 30. From here the next node is at address 500, which is the 7, and then 9. Okay, any question how we insert at any index in the list? The code initialize head pointer next node to null, where is this change the code to point to the next node. Okay, alright, so this is changed when you do the insertion. So let me show you the code. You know, the insert function that we used, or insert at index. So let us try to explain that question. So initially, as he said, this is how the list is, right? The head node is created and no data set up for the node, and the next node pointer for the head node is null, and the head pointer stores the address of the head node. So now we want to, let us see the process of adding the first data node to the list, say 10. Now we can do that using the insert function or the insertAtIndex function, because both are going to do the same thing in this case, because we're going to append to the end of the list. The list is currently empty, right? So let us use the insertAtIndex function. Okay, so let me do this. I'll copy this figure. I will create a separate PowerPoint. Okay, so let us go to the insertAtIndex function. So this is the insertAtIndex function. So insertIndex is 0, right? Because we're going to insert the first data node, and whatever the data, in this case 10. So current node pointer is going to store the address of the node next to a head node. So head pointer arrow get next node pointer. So head pointer in our example is storing the address of the head node, so that is 100. Arrow get next node pointer, and that will be 0. So that means for our purpose current node pointer, which I indicate as C and P, is 0. Okay, so this is current node pointer. Now the previous node pointer is going to store the address of the head node. So the previous node pointer will store that 100, and using that you can access the head node. Okay, so that's what these two statements do. Current node pointer stores the address of the node next to the head node, which is not there, so it is null, and previous node pointer equals 100. Any question on these two things so far? Okay, all right, so let us continue. Index is 0, so let us also type that. So index value is also 0, corresponding to the current node, but you see the current node really doesn't exist, and we'll eventually capture it now. So try to get inside the loop. How we get inside the loop? Check if current node pointer is null or not. Current node pointer is currently null, so it really don't get inside the loop for inserting the first data. So we'll come out of the loop and we really will set up the new node. So we'll set the new node and store the address of the new node in the new node pointer. So let us create a node. So I'm going to copy this figure. So let us create the node. The node is going to be at some address. Let us say the address is the same as this one, so that we can be consistent. So it's 200. So when we create the node using the new node function, the data and next node point are not set up yet. Okay, so the new node pointer stores the address of the new node. So let us say it is 200. So that means this node is set up at address 200. So again, in this course, whenever I explain things, when I say at means that's the address where that node is stored. So at 200 means this node is stored at address 200. Okay, starting from address 200, because you have member variables that will take space. So starting from address 200, this node is stored. A new node pointer stores this address. Alright, and then this next statement is set the data for that node. Set data and pass the data. So let us look at this code. We are looking at insertAtIndex function, right? So insertAtIndex function, the next statement is set the data. So let us set the data to be the 30. So the data is 30. And then the next statement, new node pointer arrow set next node pointer current node pointer. That means I am setting the next node pointer value for the new node to be the value of my current node pointer. So what does this do? So I am going to set this next node pointer value to take up the value of current node pointer. So right now the next node pointer, it need not be null, it could be some junk value. Typically operating system sets it up to 0, but let us say it is some junk value which we don't worry about. Now that next node pointer value is explicitly set to the value of current node pointer, and the value of current node pointer is null. So that means this next node pointer is going to be null. Okay, so that means this is the first as well as the last data node. There's no data node further down. And now the last statement will set up the link. The previous node pointer arrow set next node pointer, and I pass new node pointer. So using the previous node pointer, I can access the previous node, which is in this case head node itself, and still things will work. So the statement is the previous node pointer arrow set next node pointer, set to the new node pointer. So the previous node pointer arrow next node pointer will basically change the next node pointer here for the head node to what? To the value of new node pointer, which is 200. So that will be now changed to 200, and with that you are setting up the link from the head node to this data node. And that's how you are adding the first element to the list. And from here, you can add further down. Okay, using the same code. Any question? So like this, draw things out and go over the state code line by line, statement by statement, and try to understand. So each statement here has a purpose. Okay, so this is a very efficient code without any unnecessary statements. Okay, so every statement here has a purpose. So draw things like this, go through the code step by step, and try to understand it. Okay. Alright, so using a similar logic, let us do a few more functions before we stop. So let us say we want to read an element at a specific index. Okay, very similar logic as insertAtIndex. So have a current node pointer pointing to the first data node and the previous node pointer pointing to the node previous to it, which is the head node, and the index is set to 0. Okay, as we just went through. Current node pointer is null or not. If it's not null, get inside the loop. And like we check index equal to insert index, check if the index equals the read index, the index from which you want to read the data. So what I mean by reading at a specific index, so for example, if I want to read index 3, that means after we insert, the list becomes 10, 5, 30, 7, 9. So 10 is considered to be at index 0, 5 is considered to be at index 1, 30 is considered to be at index 2, 7 is considered to be at index 3, and 9 is at index 4. So at index 3 you really have 7, and that's the data we want to read. So check if index equals read index. Index is currently 0, it's not read index 3. So don't go inside the if block, just come out of it and continue the while loop, which is basically moving the 2 pointers further down. And we know by now, we first set the previous node pointer to take the current node pointer, and then the current node pointer moves further down. And then we increment the index also. So we keep doing this. When we reach index is 3 is equal to read index, that means the current node pointer is really pointing to that node at that index 3. So we can break from the we have to just return the data value, right? So instead of breaking, what we can do is, it's almost breaking, but before we instead of doing right break, you say return. Return is like exiting from the whole function with a value. And what is the value returning from this function? The current node pointer arrow get data. Return the data of the node currently pointed by the current node pointer. So that will be this 7, and that's the value I want to read. What is the value at index 3? And that is 7, and that's what this function is going to return. Return current node pointer arrow get data, returns the data at that current node. Now by mistake, the user may pass a read index that is an invalid value. For example, this list has what, 5 elements, so the valid values for read index will be 0 through 4. If by mistake user say passes 7 or some number like 11, 20 as a read index, then that will be a value that is you don't have that many elements in the list, right? So that what will happen in that case? You will go through the list starting from the head node and reach the end of the list, and still index will not be equal to read index. So we will not return from the while loop. We would have reached the end of the list and current node pointer will become null and will come out of the loop. And then you simply say return -1 because you basically the user passed the read index value that is out of the range. And to indicate that that's an error, you can say return -1 as the value read from the list. And that return value assumes that the list is going to have positive integers, or even if you have negative integers other than -1. In general, you can pass some junk value, some very large negative value to also indicate it's an error. So basically, if the user is passing any invalid value, that is how you can return the error message. Okay. Any question on this read index function? Alright, so let us do one more, the modify element function. So very similar logic. I want to now modify the data at a specific index. So let's do the same thing. Let us say we want to modify the data at index 3 to be, instead of 7, some number, some other value, and you can pass that as the data that you want to change to. So I specify here the modify index and the data. Again, start the 2 pointers and index 0, move through the list, and if index equal to that modify index, 3 equals to 3, for example, like that, and the current node pointer will be at that time pointing to that current node corresponding to the index. So using the current node pointer, you can change the data at that node. So I can say current node pointer arrow set data. So set data member function can be called on the current node using the current node pointer and the arrow operator, and pass the data as the argument, and that will change the data at that current node. And that's what we want to do. So the return type is void. We don't want to return anything, so we can simply say return and don't pass any value. So you should have seen this in 118 or 119. When you say return from anywhere from a function, you're basically what you call stopping the execution of the function, returning out the control is coming out of the function. And here we are not returning any data type, any value. You simply say return and then the semicolon. So you'll break out of the loop and return. So things like this, return statement like this, if you have not seen in an earlier course, it's time to learn this new thing. And go back and look at that book that you used for 118 or 119 or the notes or whatever. You should have seen it somewhere and go through that again. I'll still explain it in detail what this return will do, right? Returning from the loop. So it's all like a continuation, and you have to really go back and practice and try to do things until you understand completely. And then don't forget it. You have to again remember it and use that idea, use that logic and all these things in the rest of the code in the semester. So it just comes by practice. Don't give up right away things, okay? So go back and look at this code and work on these things. So I have posted an assignment 2 also, which is going to use a logic similar to what we are doing right now. So you can also work on that assignment. And assignment 1 is also there posted and it's due on the 8th Tuesday next week, and assignment 2 will be due the following Tuesday, 2 weeks from now. So make sure you attend these classes and follow these things. These are the very foundation things for the rest of the semester. Okay. Alright, so I stop with this, and let me check what time is it. Okay, so we have 3 more minutes, and let us see if